Okay, this is going now. I think we're about ready. Okay. You guys all set? All right, cool. So I'm going to just talk. I know Corey already did something on Docker, so I don't know what he did because I wasn't here. Oh, he didn't? Okay. So hopefully this will be a deeper dive and show some cool things. This is, I decided I wanted to try and make a dev box in Docker and like set up so that we would, it's a Linux environment, so that we'd have one benefit is that you don't have to configure it separately for Mac or for Windows. It's just Linux everywhere you are. So I love that. I'm using the setup I have right now at home on my Windows box, and I'm using it here at work, and they are identical. There's no difference. So that's a selling point, or one of them. I'll get into and show you some stuff. I think it's really cool. But Docker is pretty new, but also very influential. Like everyone's talking about new technology. There's two things really that you need to know about. Linux containers have been around for a while, but it takes advantage of Linux containers to run stuff in isolation. So it's as if it was another Linux box essentially, but it's not, or it's much more lightweight than like actually running a VM would be to quickly spawn off stuff. And then they have this union file system thing that it's built on, which is really sweet because they took kind of like Git, where we have Git commits, so we check them in, and each Git commit has a SHA, and like that's how you order, and you know that like stuff's in order. They do the same kind of thing with their file system, union file system layers that they use. So like I'll get in and do something on the box, like let's say I install a program I like Vim, and like commit that as a layer. And that's actually like, think of it like Git, like I just committed it, and now I can build off of that. Like I can start another box that begins from a starting point of my already having done these 2 or 3 steps kind of thing, and then just kind of go from there. I'm gonna demo some of this, and it'll start to make sense. But it's pretty cool. To run Docker on Mac or Windows, you have to run a VM to do it. So I use boot to Docker, which is just a real lightweight. Well, here's like a Linux or our Mac terminal, right? So I've got boot to Docker installed, which is really just, so it's a little VM that'll run in VirtualBox. It's already up right now. So it's got a host-only network that it sets up for itself that only I can see it. So like to expose this for you guys to get into, I'd have to do more. So I can go ahead and just SSH into this boot to Docker box like this. Oh, sorry, I named it Docker host. That's right, in my config file. And it's really like not that pretty in here, right? Can you see this okay? You can see the Docker processes that are running and all that. Not much like visually impressive stuff going on right now, but just to show you like some images I would pull down. I pulled the Ubuntu image right down. You can see Ubuntu 14.04 right there. If I wanted to, I could just Docker run, and then I could set it up with a terminal, set it up to remove itself when it's done, run that Ubuntu image with the command like bin bash. Then, oh whoops, it's actually tagged as Ubuntu latest down there. So you see what just happened? See how fast that was? That's a whole, that container has been created, and I'm now inside of it. Think of that as standing up a whole new VM, in essence. But it's much more lightweight than that. I'm on the inside of that box now. I have a different IP address than I had before. I have like a lot of other, so it's like they're really lightweight, interesting things you can do. Again, this Ubuntu box doesn't do much. It's just the stock image. It can't do anything. But I'm going to demo. I've set up this other one. My end goal here is that we as a development team can use Docker to both to develop inside of and also to share what we develop with others. So I would perhaps work on a project and then create this Docker image and hand it to you, and then you can run it on your box. Guaranteed. There's no like works on my box, doesn't work on yours. It's the same like built image that'll just run anywhere type of thing. So for deployments, we would deploy this way. For devs to sharing code, we could share it. You know, it opens up a world of pretty interesting possibilities. So I don't like that really plain boot to Docker console, and there's not much option to install good tools there. So I went ahead and I made myself just a different like box to SSH into, essentially, which is also a Docker container. Like if I look at what's running, you can see that I'm running this Bob Pace X11 Docker host that I just SSH'd into, just so that I've got like a sweet prompt in Vim and like tmux going on, like all the tools that you would like to have. Kind of cool. So like, here, let me just show you. This is what when I took that month off of work and I sat at home, this is what I was doing. So it's actually all in here. This is up on GitHub. So I've tried to document this pretty well, but this is my, actually maybe just go over there. DevBox repo. And it's got some instructions on how you could go about installing all the images and stuff, and a couple of goals, because we want to be able to use our SSH keys, but not have them be part of that Docker image that I hand to you, because I don't want to give you my keys. So we're using this SSH agent to forward the keys through. When you're in a Linux terminal like this, when you SSH in, you don't have good clipboard support. It's kind of crappy. So I went through the trouble of setting up an X server, and I'm forwarding the X clipboard through, which if you've used Linux before, this is a thing apparently. I had to research and kind of figure out some kinks and how to get that all to work. But the end effect is that I have the OS clipboard synced with every single Docker container box as I go through them. Or like it's the same clipboard, it works like it should. I'll demo it in a second. So here, just to give you an idea of what Docker even kind of looks like to get started. This is my Dockerfile that builds my dev box. I start from a base image, which is Ubuntu 14.04. You can run commands here. So like you can set environment variables. You can run any commands you would normally run from command line. But each block like this, like a run block of all that, will actually commit a layer of that union file system I was talking about. It's pretty neat, because like think of in JavaScript, when you've got a prototype and you've got an object that links to that prototype. You know how if I had like a name property on my prototype, it would shine through to my object, because does that make sense to everybody? This analogy I'm trying to use is the same with the union file systems. The layers of the union file system, like if I put this layer here and then I build on top of it, I can override it and shadow it so you never knew it was there. Or I can stack all these layers together, and to you that uses the file system, it just feels like one file system. In reality, it's like a bunch of layers of file systems that are all participating and bringing their little pieces. You know, like one directory could be in one layer, and the other layer doesn't even know about it. But to you, the user of the file system, it's just all one thing that feels like you wouldn't be able to tell the difference. But it's a neat concept. So this run command I just did commits one new layer with like all these tools that were not otherwise on the box I'm going to use. And then here, let's go down a little bit, show you some other things you can do. So you can set the user, you can set what working directory you'll be in, you can set what command it's going to run when you launch the container. So this is just a base image that I'm going to set up. So like say we want to do some node development, right? I need node tools now. So I made another image for this I call node box. Starts from dev box that I just built, and then installs node. This is, you guys seen the tools like Puppet and Chef, or like the things that would stand up VMs and automatic? This would be a replacement for some of that, because it's the automated instructions to build this box from scratch. So if you just started with a brand new computer, clone this repo, run the make commands, like half an hour later, you've got all these boxes ready to go. They're the identical box that I use. So there's strength in that. And you don't have to sit there and monkey with configuration. You've got it like locked down in one spot. Another really cool thing, I would show you more with the actual building part, but we have some iron port issues, as always, where certain ports are blocked that don't let me do what I want to do. So it's kind of time consuming and tedious sometimes to run these install commands, because it could be like a half hour of downloads and like compiling and all that. So Docker takes advantage of a caching mechanism where each layer, as you complete it, is cached. So the next time I run the command, it's going to pull the output from the cache. So that half hour I just spent downloading and compiling you complete me for them, I don't have to suffer that again and again. It's like I can make edits to the end of the Dockerfile and not go through the time it took to build the whole thing from start to finish, if that makes sense. So that helps immensely, I think, when you've got a lot to do. So, another interesting thing is volume containers you can link in. I know this is a lot of information overload all at once, so maybe I'll just like show you what you can do with it. One consequence of the Docker container is that it's, think of it like immutable state, sort of, in the sense that, or ephemeral. I'll put up a Docker container, I'll bring it down. Everything I did inside of there is gone. There's no like persistence necessarily inside of that. But if you need that, you can link in like a shared volume that is persistent that will stick around even if I take down my container and put it back up again. So there's some like, there's good things and bad things about that. I'd say mostly good things, because then you've got repeatable, consistent builds that you don't have to worry about what someone else did to it before you got there. Same argument to be made for like state versus immutable stuff, I think. It's an analogy there. But here, let's pop back out of this. So I'm on the Docker X11 Docker host right now. Let's say I want to run my node box. So like I just ran, this is another Docker container that's running. You can see node box is running right now. And I have it set up with nested tmux sessions currently. You can see the two status lines at the bottom. Now I've got node tools like npm and I guess node, right? Yeah, 1+1. So there's node. I don't necessarily need node on every container, because I only need that when I'm doing node stuff. That's why node box is a separate box. I've got a box for Go. So there's a Go box you can pop into. That's not working because I screwed something up. I've got a Scala box. Yeah, here's a Scala box. So when I was doing all this stuff, the clipboard support is like crazy, because you can't carry clipboards through here. That's why I spent some time trying to get Xclip with an X server to work. So like I made a little script that makes sure it works when you go through to new containers, because it'll forward it through. But the end effect is that I can have say a tmux pane over there on X11 Docker host still, but on this left side I'm in Scala box. So I'm actually on two different boxes right now. Like there are two different IP addresses. They're two different everything, you know, as far as it's concerned with the containers. I've got a Vim instance over here, a Vim instance over there. I can take some content. I screwed up this one key binding. There we go. So I can paste right over there. So even though I'm on separate boxes, I'm sharing the same clipboard and forwarding that clipboard through, just for convenience. Otherwise, it's kind of a pain. So my end goal here is that we could just, because it's a pretty sweet Vim install with like some plugins that only work really well on Linux, I think, like Silver Searcher. We had issues trying to get that to work on Mac. You just don't have to worry about what works and doesn't work on Mac or Windows. You just go, everything works on Linux. So let's just run it all where it was meant to be run. Some neat tools, I guess, that are just more Vim related. So I can like pop up. Here, let's see. Oh, I actually encountered a fun bug. That union file system thing I was talking about. The order in which you bring the volumes in matters. Because if, let's say I bring in a volume that's home/dev user, and then I bring in another volume that's home/dev user/data. If I brought those in the wrong order, one would take over the other one and you wouldn't even see it. So like maps in Go right now have randomized key access, or that's just a thing. So if you stick in, it's like a dictionary in Go. So if you put 3 keys in a dictionary and then range over it, it's going to be random what key you get in order. That's a Docker bug right now, because the mounts are just mounted that way. And they fixed it, but they haven't released a new version yet. So sometimes when I open my boxes, the mounts go in out of order and the folders aren't in the right spot. That was bugging me for a while, but I've since stopped trying to fix it because they fixed it themselves. I just need to get on the latest version. But that's in there. Let's see. So in here, if I want to come into this app right here and just show you. Actually, here, let's go to this one. A Silver Searcher plugin is pretty cool. It can find stuff. Maybe if I get it to, you can like bounce around, find usages in your app. See, I'm like just jumping around. That's that find all usages from ReSharper type thing, but in here now, you can like make it just hide if you want. That was a plugin I could never get to work on the Mac, so kind of neat. So yeah, stuff you would actually do with this then. So if I'm in like the Scala box like I am right now, I would maybe run the activator. I think I have an activator script. Maybe messing up. An activator. Oh, maybe it's not. Oh, let's see what's going on there. We'll do the node one instead. That mounting gets you though, because like that just happened. You see when I came into data and there was nothing there just a second ago. I was going kind of quick, but when the mount's going out of order, it just like his folders just don't show up. That's going to have to be fixed soon. I would get in here and maybe like run the Webpack dev server from here, and then one of the interesting things is, I don't know if you can see over on this right side. But the container called Nodebox is the top one right here. I'm going to highlight it so you can see this thing, Nodebox. I've forwarded some ports. So if you see this information that's sitting right here, you can see that on this container I'm running, I'm going to host a service on port 8080. But then I can't just get to that from my box. So I'm going to have to bind that port out to the host box. So like say that 49.183 right there, I can hit that in my browser. I come over to this guy, say Docker host 49.183. If that's the right, yeah. Should be able to see like it pops up this. I don't have it doing much other than just saying hello in the console. But this is like how you can, from my Mac browser, go and view like a web service I'm running in on a Docker container on the inside, so that I could do my back and forth development, like have it over here. Not tiny with this resolution, but the other one. And maybe like set up a Vim. And just kind of sit here and type on, like maybe here, you know, hello with a, you can see on the right side, just picks right up. So that's that same thing I demoed last time with the Webpack dev server, but it's just, you know, hosted from a Docker container now. And that, I think it'd be pretty cool to just, like, let's say I'm working on a project and I can just like hand you all the images. Like it could be more than just, it might be a web app running with Node with a Postgres container that, you know, that's the database, all that stuff. I can just hand that over to you. You can just, you don't have to set it up on your machine or anything. It's just like, actually, I want to show you that right now, actually, because I am running a Postgres thing as a Docker container. That's the third one down there. You can see Postgres latest. I didn't build that. It was not hard. I cloned it. Someone else made it. I just started, and like, boom, I've got Postgres running. And then when it comes to containers, you have to link them together. Like if I have an app, it needs to talk to a database. I've got to like link so that they can talk to each other. Because by default, each container is its own private IP address. They don't know about the outside world. They're not touchable, pretty much. So I would run I'll pop back out of here. Oh, whoops, I think I went too far. Okay, so I would run my node box, but at the time I'm running it, I would link, I've got I called it example Postgres, and I'm going to link it as Postgres. So now that I'm in here, it's kind of interesting because if you look in the hosts file, it actually included an entry for me that wasn't there before called Postgres over to that IP address. See that? 172.17.08. That's the Postgres container IP address. So now I can talk to it. I can like ping it, and like I'll get a response back. And then it does also, when you link, it sets a few environment variables for you. So in the Postgres container, as far as it's aware, it's hosting Postgres on port 5432, which is the default port Postgres runs on. But in reality, when I link it in, it can be any port I want it to be. I could like forward it out to some other port. So if I want to run 10 Postgreses, they can't all be on the same 5432. That doesn't work. So we've got this. I don't have to think about what configuration it's going to be later. I can just set it up in the one way that makes sense to me, and then set up 10 of them later, and who cares, because they'll all be on their own ports later. So here, this little SQL file I can get to. Oh shit, I had that same volume mounting problem. Oh yeah, so that SQL file, I'll just, whoops, in that SQL file, to show you that. So this is like some, I've got that DBEXT plugin for Vim. I don't know if you've ever seen or heard of that, but it lets you use Vim as a SQL management studio, essentially, to do all your SQL queries and table stuff. So it's like this table right here. I can just go select results. See down there? I can get, those are what's in the table. And like I could go list tables. These are all the Postgres tables down there. But the cool thing about this, this Docker or this Postgres image I just linked to, I could have this one be like, say, dev or something, right? I could just run the node box, link it to a different Postgres container, and now I'm interacting with a completely different Postgres database. None of my inside like Vim plugin connection string is different. It's the same exact connection string as far as my thing in here is concerned. It's just which Postgres thing I link to my inner container. I think that's freaking awesome, just because then it frees me from any kind of configuration concerns at all. I just be like, I know there's a Postgres container in the mix, and whatever it is, you can decide that later, but I'm going to connect to it this way. So I've just made a dumb little customer table and inserted like a row just to show you that you can select from it and do stuff like that. Just to get into that teeny bit more over here in the plugins for DBX, you can see what the connection string information actually looks like. So the host is bound to an environment variable. It says Postgres port 5432, whatever. Remember I showed you the environment variables that when you link a container come through like that. So you should see some post. Oh, whoops. You kind of have to keep straight what box you're on. See down here I'm on X11 Docker host. Up here I'm on node box. So you kind of like Inception, where you're like going a couple of levels deep here, and then you gotta come back up out of it. So my hope with this is that this makes development fun and like quick, just because there's a lot of tools here that once we get into, I think we're gonna really enjoy using. But trying to work out some of the kinks with it. Is this interesting or exciting to people? Is that anybody have previous Linux development experience at all, or like a lot of this is new to me. I'm just trying to like sort through some issues with it. So I don't know. Anybody have any questions so far about any of this?
So that's what it has around the containers. You literally just send someone else a file, or you have some sort of like repo where you put them?
Yeah, they have similar to GitHub. They've got Docker Hub. Docker Hub exists for that purpose. So like maybe we don't want to use the public one. We can stand up a private one, just like we've got our own private GitHub here. And then I could just push my image up there and you could pull it down. It's just like Git in that sense. It makes sharing these things really easy. So one cool thing too is that, let's say we have a build that is version 1 of our product, and then 6 months down the road we need to stand it back up again. It's just an image sitting in, like, I just grab it and launch it. It's there's no like rolling anything back or like anything. It's just that was a completely runnable, executable, launchable thing as it was, just sitting there like archived forever. So like kind of neat, a little easier than what we would have to do now if we ever had to do it. What's up, Mike?
So you're saying Dockerfile is kind of like our build artifacts now. If we were to build a container, and that's like you could build the artifacts, have the deployment, but you could put your container up on Dockerfile and have it versioned.
Yeah.
Like that. Except it's more than artifacts.
Well,
right.
The image you put up is like it's the done the product ready to go. Yep. It's like.
But it also, I mean, you can just file copy, right?
Sure. Or I mean, you can. There are a lot of ways to hand it over. You could just like zip it and hand it to somebody. And there's an import feature for Docker that lets you bring it down through means other than through Docker Hub. But or in my case, I just have the actual instructions to make it from scratch on that. So I mean, that it takes longer, but it's repeatable. As long as you have an internet connection that's not behind Ironport, then you're good. So,
how large do these image files get?
Oh, that's a good question. And like, I'll show you. So like, look in here. So the images that I am currently holding on to, you see the Scala box is an embarrassing 2.5 gig compared to the other ones, which are like 800-ish. So the raw Ubuntu image, was right there. You see it's only 194. And then the amount of packages I installed on it brought it up to 872. And then for the node box version of it, the additional installation of all that took up, an extra 20 meg. One cool thing, remember that union file system we keep talking about? We share layers. Like we're all from the same dev box image. So when you see dot files taking up 909 megabytes and DevBox taking 872 of that is the same amount of space that we're sharing because we built off of that image, if that makes sense. Like if you were to just look at the stack of layers, we share the first 10 or so layers until we split, and then we do different things. So we're not duplicating the storage necessary to hold on to those 800 megabytes. Does that make sense?
So you're saying that the 909 megabytes, they include the 872 megabytes of the other box?
So the difference between the two is what I really just added, because as far as the file system is concerned, it's the exact same layers contributing to that union file system.
And if you tweak the dev box, you are automatically tweaking the dot files.
Because, or any box that builds from another, if you rebuild the base, you'll have to rebuild what you came from. But I structured these in a way that the things that I have to rebuild a lot, I don't want to spend the time to go through all that painful, installing, downloading. So like dot files, you change those pretty frequently. So I moved my dot files out to a place that I can nuke them, blow them away, and completely recreate them without hurting any of my other stuff, just because I do it too often to want to sit through the time. And the same with, like when I launch a container and I go run Scala stuff, it's painful because I have to sit through like 45 minutes of downloading packages and whatever. And like if I were to just kill that container and restart it, all of the downloading and storing of those files is essentially gone because it's like a ephemeral container. It doesn't exist anymore. In that case, for me, what I did is I made this SPT cache, which is, see how it comes off BusyBox image, which is a 2 megabyte image. It's like a teeny little Linux install. And its only purpose is to share a directory. Like literally all it's going to do. And I'm just going to volume mount that in so that that's my permanent persistence for where I download my SPT dependencies to. So I can stop and start Scalabox over and over. And anything I've ever downloaded before is still there, just because that's how I'm bringing it in. That's the neat thing about Docker containers is you can splice them together from anything. I'm like, this is a box, but I'm going to bring in this volume from here, and I'm going to bring in whatever I want, just layer it all in on top of each other, and it's like, boom, here's your box. It's like there's a lot of interesting things you can do with that. which is kind of neat. And then if we were like on a Linux box to begin with, then this would be a pretty decent way to get going on how to develop. And I like it personally because now I don't have to think about the Windows or Mac inconsistencies anymore. I can just go home on the Windows box, do it, get here at work, pull it down. Like so far, I've worked out the kinks to where it behaves the same way. You have to run, like I said, that X server to share the clipboard. For a Mac, that's X quartz. You just have to pull that down and run it. For Windows, I use Xming, yeah. But it's just, again, just like start it. As long as it's started, you're good. You can share that clipboard throughout all this stuff. That was getting me for a while because it's real painful to copy paste from window to window. So, what's up, Brad?
So how to deploy something? Are you actually just overwriting?
Oh, well, and everything I'm showing you right now is all for a development experience for you to make something. Once you've made something, that you would build again into another Docker image and host it without any of what I've got here. But you would maybe just pull the official node image, add your code to it, add a run command to npm install, and expose of the port it's going to be on, and then the command to just run whatever that is, and then hand that image to somebody. And then that's the app.
So once you did that, literally overwriting.
Oh, no, they version. So like this Ubuntu thing you saw has that 1404 on it. If I push another image up called Ubuntu, it's gonna up that. So you have to increment. You can't override an old version on your Docker Hub registry. So like, or once you publish it there, you're not supposed to get rid of it, I guess. It's like a permanent artifact at that point. So you just bump the version number. And then latest will always point at the top one. They advise you not to use latest in your actual Dockerfile because it just might bite you because you'll get an update that you didn't want or something. So, and also when you name your repos, see how I've named them like Bob Paste / that's a naming convention that Docker Hub wants you to use. If that's just your Docker Hub username. So if I wanted to Docker push this, that's where it would go. Is up to my repo. And then you could pull it by that name. So this frees you from a lot of the complexities in installing services too, because someone else already did the work. So you want, I know Matt right now just stood up a Jenkins server and stuff with Docker, but you didn't have to go through the installation. Did you just pull the image and kind of, yeah. And then you don't have to worry so much about, you know, if you're just tinkering, you're not leaving behind anything on your computer that is, you know, this is kind of like a sandbox for you to play in and make sure you get it right. That doesn't leave anything behind. And then you can even do 2 or 3 of them too, because it's like kind of pretty interesting and powerful stuff. It's still kind of getting into the beginning of it. So, but yeah, this could be the development experience if you want it to be. Like just terminal, like run it all from there. Like be like Vim lords or whatever. That's what I think. It's pretty good. Did I see any other hands? I thought I did. Yeah.
If there's an update for your packages inside your Docker container, you have to rebuild it from scratch.
Yeah, I think of it as you don't really update containers, you just rebuild them in that sense. So yeah, if some new version of something comes out and I want to rebuild all my containers against that new thing, I would just remake them all. But then hopefully the way you structure your Docker file, if you push the things that are more likely not to change higher up in the file, you'll be taking advantage of the cache so that new things that might change more often, I just put at the bottom because then you'll use all the same, like those just go really quick. So like in here, for instance, if I come into my DevBox repo and I just say like make DevBox, this would normally take 20 minutes, but you see it just pulled everything from the cache and it's done in like under a second. So it didn't actually do anything. It just, because it sees there's no change, and so it just leaves the image that it had before. But that's as quick as it is to change something. So if I popped in here and said down here on Dockerfile, you know, add one more run something, do something new, it would use the cache up to that last spot and then just run that, only that end spot as a new thing. So that's really convenient just for a time saver. I thought I saw a tweet about somebody complaining about how long apt-get installs take for vagrant VMs and stuff. I'm like, this might help, because if you got to do it over and over, might as well save yourself some time with that cache. Although, and on the flip side, that cache can hurt you, because if you push an update and you want that, and you just build it and it's in your cache, you might not get that update because it doesn't know that it changed. So in my case, like for my dot files, I purposefully build my dot files with what's the make file? Sorry. Down here, I do this -- no cache. Down here, it forces it to run fresh every time. Like if I make a change to my dot files, like maybe add a Vim plugin or something, I just want to be able to pull that. I wonder if I could, should be able to do that right now. I'll remake my dot files just to show you what it looks like. So my goal here was just to have it actually have installed all the Vim plugins before I open Vim for the first time, so I don't have to sit there and wait. And this is what it's doing, essentially. But it's doing it onto a volume container that I symlink some files back to the home folder on. There's some trickery there. But in essence, I can nuke my dot files and re-clone them like this, and the amount of time taken is just about done. It's like almost to the end.
So your Docker container is like, let's say 1 gigabyte size, and you just do a really minor update. You have a newer version now.
Yeah.
Does the user have to download a whole gig of update instead of just that difference?
Oh, well, if you're just pushing images and the only way that user is getting them is by downloading the images, then I guess, but if they were just making it themselves and just pulled the latest of like, say you committed that Docker file to a GitHub repo, and then I cloned it, but I had previously built it before, the cache is still good. And only the difference between what it was before and what it is now is what it will build. So, but either way, I mean, sometimes you might just hand them the image, which, yeah, it's a gig. It'll take that long to download.
It's not quite a gig. Because of all those layers, even when it pushes up to Docker Hub, it pushes up all the layers individually. And so if you only change like the top 3 layers, it'll download those top 3.
Yeah, but if you make a significant enough change, like high up in the file, that it's got to just rebuild everything, you'll still have the old image. It'll just show with no tag. Like here's Docker images. You can see this none entry that is there now. That's my old dot files, but as I built it again and tagged it with the name, so the name's not available for the old one to have anymore. I can just get rid of that. I just have a little shortcut to get rid of untagged ones. So I'm using it right now, so I can't kill it. It's good protection. Let me get in here real quick and show you. So, yeah, oops, left that up. I'm going to stop node box. Normally I wouldn't kill it this way, but I just want to show you real quick. Like a harsh killing of the. And get rid of it. Oh, it is gone. Okay, and then that X11 Docker host too. I'm gonna kill that. It's also using my dot files. And then now that no one is using my dot files anymore, I can remove my dot files, and now I can get rid of that old untagged image. And it'll go away. So I just have this little script that cleans up after myself. So if I don't want to leave behind like just tons and tons of old images that aren't useful anymore. So I just clear out anything that's not tagged. And now I'd have to run it again. So I'd run it with the name dot files, and it's my bopay/dot files. And now that was in essence what it takes to update my dot files. It's just rebuild the container, kill the old one, start a new one with the same name. And then now if I go and launch, I'll run my X11 Docker host again. Out of this, I don't like, so the boot to Docker VM, it's a 6 megabyte Linux install. It's got nothing on it. There's no ability to download new tools to it. If I wanted to rebuild it and figure all that out, I could do that. But instead I just am like, I'm gonna SSH into a different control center, that I make for myself and build with all my tools in it. So I can actually feel like I can get something done in there because the Docker VM is kind of lightweight. Well, this should actually yell at me. Oh no, okay, we're good. One funny thing is, while I was trying to figure all this out, I would rebuild this Docker host over and over, and then I would try to SSH into it, and it would be like, warning, man in the middle, man, attack. Like you're being attacked. Like someone has changed the key of what you thought it was. I'm like, no, that was me. Just like, get it to be quiet. But, so now these are my new dot files. If I had made a change, I'm like running again with them. So
when you are building from the cache, from Docker's cache,
yeah,
how fine grained is your control over what to use from the cache and what not to use? So like let's say you have some npm package that you're dependent on, and part of your Docker layer is downloading that npm package specifically, and you make an update to that, and you don't want to like blow away a whole, like your whole cache. You just wanted to
just that, yeah, the end.
New npm package. How would you?
I think the best practice for that would be the part you want cached. Write the Dockerfile, just that in it, and then start the other Dockerfile from that one, because at each new instruction is a cache step. So then, and then also one rule is any add or copy is always not from the cache, because it's a file you're adding in to the image that comes from the outside. It can't be cached. So I would say put all the whatever's there that you want to stay there on an image that you lock in place, and then make a whole new Docker file that is from that image that does the stuff that you don't want cached, and then just never cache that. And then should be fine. But yeah, it's a lot to take in, and pretty cool though. Spent about a month screwing around with it so far. I think it's. Does anybody else have any questions or want to talk about it in other ways? Like, 'cause I mean, there's some things I need to smooth out about the experience of using it. Like that clipboard thing, I just got done about like 3 a.m. last night, so it's a recent addition. By the end here, I hope to have something that's going to just be nice to use. I even had Jason Staten help me out a little bit. He contributed some pull requests on my repo. I didn't even say anything to him. I was just like, or I woke up in the morning and I see like 2 pull requests from Jason. I'm like, holy crap, like someone's looking at this. So, but yeah, it's different than what we've been doing, and it would take some time to figure out how to do this. But if you know how to drive Vim and just get around, you're not going to be too far out of your element to get in and use these tools. It's just command line stuff. And it's kind of more like a self-service thing too. I was reading that my pipe dream here, whatever, is that if we get our IT guys doing this, and then we can turn our like stuff into more of a self-service. Like I need a new box, I can just like, here's a container image that IT's bought off on that works on our iron port, and that does all that crap that they've locked in once. And then I can just self-service and go out and start 3 new servers if I need, without having to go through all that. That's how some businesses work. We could get there. But, so yeah, that's pretty much most of what I want to show you. So unless there's any other questions, I'll probably wrap it up. So, all right, yeah, thanks for coming and listening, guys.